So we start with a new topic called natural language processing. So in this topic, right, we'll first look to the definition of the natural language processing. So NLP is a field of artificial intelligence that enables computer to understand, interpret, generate human language to process modalities. For example, text and speech, allowing computers to analyze and react to human communication in a useful way. So basically, NLP tries to provide the computer to understand, the interpret and generate human language to process certain modalities, for example, text and speech, where the computer tries to analyze and react to the human communication in a useful way. So, in summary, NLP is the combination of computer interaction and the human language understanding. Next part will discuss about the objectives of the NLP. So, in objective of NLP, so first objective is the language understanding, where it tries to enable the machines to comprehend text or speech, such as semantics of the text or the syntax of the text. Next part is the language generation. In the language generation, it tries to enable machines to produce a natural language text and speech. Similarly, for machine interaction, it enables the human-computer communication using a natural language. Next, coming to the components of the NLP. So it consists of two main components. One is the understanding of the natural language, and second part, how to generate the natural language. So in the NLU, that is the understanding of natural language, it actually interprets the meaning from the human language. For example, tokenization of any word sentence, phrasing of sentence or words, parts of speech, tagging of a sentences, name, entropy recognition, entity recognition, or the sentiment analysis of a human motion. For example, whether the human is sad, depressed, or kind of a happy. So in the language generation, it produces the meaningful text to speech or speech from the data. So for example, I want to do a text summarization, story generation, report generation, or make a chatbot. Okay. Next, coming to the next slide, we'll discuss about the major tasks in the NLP as mentioned in the previous slide. So first task is the tokenization. So tokenization is a process where it splits the text into smaller chunks or the units into words or subwords. So for example, AI is smart. So I make a split or chunk as AI is and smart, which is considered as an individual token. Next is stop word removal. So it actually removes the common words which is not useful, like for example, is and the. So in this sentence, the cat is cute. So we remove is. So the final token is the cat and cute. So similarly, stemming and lemmatization. So there is a concept of stemming and lemmatization. So basically, lemmatization is a part which actually finds an exact word from dictionary. Okay. So for example, running. So it provides the output, the exact word from the dictionary is the run. So this is lemmatization. Stemming is a process which is not necessary to find the exact word, but it find from the root. Okay. So what does it mean? So for example, here running, in stemming it can find run as well. Okay, so it's not necessary to find the exact word from the dictionary, but rather find the root of the word. So next part is the pose, that is the parts of the speech identification. For example, here AI is powerful, so AI is a noun, is a verb, and powerful is an adjective. Correct. Next we find the name entity recognition, which detects or finds the entities like the name of an entity, dates of the location of any place. For example, Google is in California. So organization belongs to the Google, location is California here. Next is the dependency phrasing, which find the grammatical structure. For example, for any subject, whether it has a verb or not, irrespective of the object. Okay. Next is the sentiment analysis. It detects the emotion. So, for example, emotion of a person can be right whether the person is happy, sad, or depressed, right? So, for the text right given here, I love NLP. So, it provides positive sentiment. Next part is the machine translation, where it translates the text between the language. So, hello. So, the translation in let's say in Germany is the Hola, German language. Next is the text summarization. So it provides a concise summary of the purpose of the text or the paragraph given by the user. So here the NLP is a field, rest of the sentences is given here. So it summarizes. NLP is a AI field for language. Next is the question answering task. It finds the appropriate answer from the text, right? For example, who is the CEO of the company? So I'll say, right, ABC is the CEO of the company. Next is the text classification task. It categorizes the documents whether it is a spam or not. So, for example, whether the email is spam or not, so that can identify it. Okay. Next, we come to the part of a common techniques in NLP. So I'll just take a different pen here, right? So first part is the text processing. So in the text processing, so similarly, it actually takes the tokenization, stopword removal we already discussed, and the lemmatization, right? So description is the basic text cleaning here. So next is the feature extraction. So in the feature extraction, right, it contains the bag of word. Next is the term frequency, inverse document frequency, or the word embedding. So we'll discuss this topic in the next lecture. So the description or the purpose is to convert the text into a numerical features or the categorical. So categorical information to numerical. So for example, in a kind of a bag of words, the male and female. So I categorize the categorization of the information is the male and female. In the numerical way, I present man as 1, woman as 0. Okay. Next, there are certain statistical modeling like Engrams, HMM, CRF. So these are the methods for sequence modeling. Next is the deep models. There are different deep models. We already know RNN, LSTM, GRU, and the transformer. Right. So these are the neural network architecture model, and the pretend models. Right. We will see like later in later lectures. Right. BART, GPT, T5. That is the text-to-text transformer, ExcelNet. So these are the transformer or the LLM-based model for training large corpus of data. So next, coming to the important algorithms, right, used in the NLP. So one popular is the naive-based. So we already discussed the naive-based algorithm, right, which actually do the classification task, right, whether, for example, the email is spam or not, right. So example is a bag of words and NV. Next is the algorithm is the hidden Markov model, HMM. So it do the POS tagging, that is the part of speech tagging, right? So it provides the sequential labeling. Next algorithm is used in the NLP is the conditional random fields CRF, which actually do the structural prediction, for example, the chunking of words or the subwords. Next is the recurrent neural network, which also does the kind of stuff. For example, sequential modeling, right? There is a sequence of words, right? Out of it predicts the next one. Okay. Now LSTM or the GRU algorithm handles the long-term dependencies of text. For example, using analysis of a long corpus of the data, it actually provides the sentiment of the words, right? Whether it provides a positive sentiment or a negative sentiment. So there are transformer model as well, like it does a parallel attention based model, right? Like for example, BART GPT and the text to text transformer model. So here we are considering an example. So let's say I am just providing an input like AI is a powerful language. So after tokenization, it tokenizes into different tokens, right? AI is a powerful language. Stop what we already seen, right? So we will remove is a here. So after removing it becomes AI, powerful language and model tokens. So lemmatization, we already discussed what is lemmatization. So it provides the exact word from the dictionary, that is AI, powerful language and model. Okay. So after doing the future extraction, we provide the word embedding or the term frequency inverse document frequency. After passing to the future extraction, we pass to the different models. For example, transformer, LSTM, based or CNN models, right? And we get an output sentiment whether the text provided here AI is powerful is a positive sentiment or not, where the category is the AI. Now coming to the last slide. So there are certain evolution metrics to provide the KPIs matrix in the NLP. So for the classification tasks, the matrices are accuracy, precision, recall, F1 score, which you already discussed. So the description is the sentiment analysis or the spam detection. Translation, right, or the translation of language or words or big corpus of data, right? We take the matrices BLU or ROG, right, which does the similarity checking in the text with reference. Language modeling has a matrix called perplexity, measures the prediction uncertainty. And summarizations, like let's say for example I have to summarize a paragraph, right? It has a matrix called the ROG, does the purpose to fulfill the overlapping with the reference summary. So NER POS tagging, so the matrix is F1 score, where it actually provides the sequence labeling or the accuracy. So these all matrices I already explained in detail in previous lecture. Okay, so thank you for watching this video. Please subscribe this channel. Thank you.